do not have slides. This is the material. So what we will do today is I will give you a short introduction to MLOps, and it will be very hands-on as possible. So I will do everything here, well, almost everything. I will copy and paste some things, but it will be very hands-on. So a few things about me. So I've been doing machine learning for 10 years probably now. And some time ago, I happened to start the community, Data Talks Club. We talked about that. And in Data Talks Club, we have different courses. They're pretty long courses, like 10-week course, 4-month course. So it's machine learning course, MLOps course, and data engineering course. So what I'm going to show today is a version of the big MLOps course that we have, which is like almost 10 weeks course. It will be, of course, it's not possible to take a 10-week long course and condense it into 90 minutes. So the idea behind this workshop is to give you the taste of MLOps. What is it? And we will talk more about concepts rather than specific tools. There will be one tool that we will talk about, which is MLFlow. Maybe, yeah, it's mentioned somewhere. But the rest will be just more concepts than tools, right? So what we will do today in this workshop is we will take a notebook that a data scientist created. And then we will turn this notebook. First, we will edit this notebook. We will add experiment tracking there. Experiment tracking is when you experiment with different model parameters, with different preprocessing methods. So we still want to track experiments. So we'll talk about that. And then we will take this notebook and turn it into a machine learning pipeline. It will be a script. Then we will talk about model registry, a concept where, like a store, where you keep the models, keep and retrieve from the store. And then we will talk about taking this model from the model store and serving it in such a way that you send requests, you get responses. And then finally, we will talk about monitoring these models. So that's roughly the outline. Yeah, I think there is a plan. So the idea here is that we finish in approximately 90 minutes. You're free to follow along if you want. Yeah. And I think that's more or less it. Yeah, if you have any questions during the workshop, you can just raise your hand and ask this question, and I will try to answer. If you follow along and if you get stuck, you can also raise your hand. And if it's something simple, I will reply right away. If it's something, I don't know, when I don't know what's the problem, then we will talk about that at the end of the workshop. Yeah, also it will be a bit interactive. So right now, before we start, you can take out your phone and then get this screenshot, get this QR code. I will ask a few things. But it will be like just 2 or 3 times during the workshop. And I am pretty sure most of you, probably everyone here, already have heard MLOps. And I want to start with discussing what MLOps is and ask you, what do you think MLOps is? If somebody wants to say, like, just raise your hand, and like there is no wrong answers. And I cannot really see any hands. I don't know if there are no hands or the light is. It's fine, like if you don't want, and I can just tell you what I think. But before that, I'm interested what you think about that. No? There are no right or wrong answers. Like I will not make fun of you, I promise. Oh, please.
Simple answer would be to use DevOps, the DevOps philosophy to do the data maintenance cycle. Something like that.
Yeah, everyone heard that? or should I repeat? So the answer was using DevOps principles applying to data. Well, it's more like machine learning, which is data related. So there is a concept data ops, which is more like for data engineering. But the core, like it's 100% correct, yes. So we take the principles of DevOps and apply to machine learning. So it's more about processes and how we as a team work together to actually productionize machine learning models. So there is a model and we want to put it into production. And it's not only about the tools. There is a very common misconception that MLOps is just, okay, here you have like 5 tools, you use them and everything becomes super easy. It's more about how you use these tools and how you as a team work together, like how data scientist works with ML engineer, how they work with a platform engineer, and things like that. So it's about organizing your work and following these DevOps principles. Anyone wants to add anything? No?
It's like software engineering, you want to make the models reproducible and also to have all the CI/CD. But it's more complicated in the data science projects because sometimes the models start from bad and it's not just like to correct the bug, right? You have to do the lifecycle.
Yes, so it's about iterating on the models, and some of the principles and we'll talk about MLFlow today, allow exactly for that, like iterating and collaborating between different roles in the team. Okay, so and there is also an article what MLOps is. And by the way, so this, I don't know if you can see, so this GitHub repo, maybe I should have created a QR code for that. So everything I talk about will be in this repo. So I think organizers should share the link somehow. But if you go to like my GitHub repo, it will be the first repo there because I updated it today. And there is also an article where I talk in more details what exactly MLOps. Right now, I will not go into details because like the answers you two gave is sufficient for this workshop. And there are, of course, different definitions from different vendors, from different thought leaders. So it's slightly different, but the main idea is we use DevOps principles. And so what I have here is I have an instance that is already running on AWS, but any environment will work. So if you have Windows, if you have macOS, if you have Linux, you should be able to follow along this tutorial. So here for simplicity, I rendered an instance, and the only thing I did on this instance is I installed the latest Miniconda with Python 3.11. And yeah, I think I also installed this JQ tool, which we might or might not use. But like the main idea here, it has Python 3.11. In my case, I used Miniconda, but you can use whatever distribution you want. And that's it. We don't need anything else for this workshop. And here I go into a little bit more details, what exactly the type of instance I have, but it should be 100% reproducible on any environment. And I already have, I have installed some things. We'll talk about, maybe it's actually a good idea to talk about this now. So the first thing I want to do, and I think I did when preparing for this workshop, I installed a tool called ppenv. Yeah, it's already there. ppenv is an environment management tool in the Python ecosystem. And I wanted to ask you, now it's time actually, if you haven't scanned this QR code. So I wanted to ask you what kind of environment managers do you already know? So I will run this thing. So there are many different environment managers. Maybe you've heard of them. Conda, ppenv, yes, the ppenv, this is what we are going to use today. And I'm curious if there are people who didn't use any. Don't be afraid, it's fine. Like for me, it's interesting how many of you, like what's the level here. Yeah, so somebody actually didn't use, 2 people. Yeah, thanks for sharing that. And interestingly, Conda is the most popular. So these tools allow to create an isolated Python environment where we can install all the packages and it will not affect anything else in other projects. So that's the main idea. So I am a big fan of ppenv, but like other tools like Poetry, it's pretty much the same. And Conda, so this is a data conference, so that's why most of you have used Conda, because like in the data world, it's pretty popular. So ppenv is a little bit more convenient, in my opinion, than just virtual environment, because it uses virtual environment and adds a few things on top. So I see that not many of you used ppenv, which is probably a good thing, because you will learn in this workshop how to do this. And yeah, so what I will do, I have already installed. This is an empty directory. There is nothing in this directory. And I will create 2 folders. So the first one will be train, and the second one will be serve. So we will talk about training the model, then we will talk about serving this model, and there will be another thing, which is monitoring this model. So for now, I will just focus on the training thing. And we need to install a few things here. So first, we create a virtual environment using ppenv. So here we just say we create an empty virtual environment using Python 3.11. So let's say if you want to use 3.10, then this is how you do it. And we install multiple dependencies. So these are things that we need to read the data, which is like pandas, PyArrow, and PyArrow is like a tool for reading Parquet files, because we will read Parquet files. Then Scikit-Learn, a framework for training models, Seaborn, a framework for visualization. And we will install also Jupyter. So if you notice here, I used 2 lines here. So first I do ppenv install and then the library I want to install. And the second one is the same, but with --dev. So this --dev lets us define dependencies that we only need for development purposes on our laptop. But when we package our project, we don't need this for serving. So we use Jupyter only as data scientists, ML engineers, locally on our laptops. But when we put this inside a Docker container, we only install like usual dependencies, not dev dependencies. So ppenv allows us to define this sort of dependencies, unlike usual virtual environment where it's a little bit more complicated. And another nice thing about ppenv, so let me now open it in. Okay, it doesn't see the new files yet. So it created 2 files, and then maybe now we will have something. No, not yet. Sorry?
You need to be in train, not serve. Make it train.
Yeah, right. Thank you. Okay. Yeah, so this is the log file it creates, and it lists all the dependencies we have, including the versions. So we kind of pin down the exact version of the dependencies and dependencies of the dependencies and so on. So this is very convenient. And so if something happens during the build process, this tool will let us know that something is shady, and then it will stop the process. Right? So it's very good for reproducibility. Unlike usual virtual environment, there it's more difficult to do. Okay, I will not go into more details. So now here, this is all the dependencies we installed, like Scikit-Learn, Pandas, PyArrow, Seaborn, Jupyter. And yeah, there's one more thing we need to install if you're on Linux. Oops. Jupyter will not work without this thing on Linux. I don't know why. And yeah, so what we will do in this workshop, we'll get a model that we will suppose data scientists trained this model and gave it to us. So now we want to kind of productionize this model. So I will now download the Jupyter notebook, and then I will open this Jupyter notebook and show it. Jupyter notebook. And then everything I run here, I need to prefix with ppenv, because I run it in virtual environment, ppenv run. So then you will use Jupyter from this virtual environment. And then I just open it. And this is the notebook we will work with. And what this notebook is doing, so it uses the New York taxi trip dataset, which is a dataset about different taxi trips in New York, obviously. And what we want to build here is a model that predicts how long a trip will take. So imagine that you're, let's say today, to get to this venue, I got an Uber, right? So I opened an app and I said, okay, I want to go here. And then the app told me that to go here, it will take, I don't know, 11 minutes, something like that. So we want to build a similar model here, or actually like data scientists already built, and we get this model, and now we want to deploy it. So the scenario we'll model here is exactly that. So we want to create a model, and then, I don't know, I get my phone, open it, and yeah, we want to send a request to our model service and get a response with the prediction how many, in our case, minutes, I think, will take us to reach from point A to point B. So this is, like, I don't know how typical data science code is. I was a data scientist for a long time, and usually I created far messier notebooks. But this is like some things are happening here. So there are like some functions for reading a data frame. So right now we will use this function. So this function, it does some data preparation, some data filtering, data cleaning, and again, some data preparation. So we don't need to go into details. The important part here is like we read this data. So we'll use data from 2022, January and February. So January is our training data, February is our validation data. And here is some code for training the model. So we have two steps here. First, maybe I will show you the data. So this is how the data looks like. And the interesting, like there is a lot of different things happening here. So for us, the interesting is pick up location ID, drop off location ID. Then the trip distance. Here it's the distance in miles. And duration. This is what we predict. So we'll just use these three features. Yeah, so that's what we will do to predict duration. We will use. And what our model is doing, the first step is taking these categorical features, like the location IDs, and using one-hot encoding to turn them like from categories to vectors. Right, and then, so this is how our training data looks like. It's a sparse matrix with all these features. Like if you don't understand what's happening here, don't worry. Like here, it's not super important. But it's a model, and there is inside what we can call a pipeline. So the first step is taking our data, the data frame, and turning this data frame into like this matrix, right? And then the second step would be taking this matrix and then training a linear regression model on top of that. I'll execute that. And yeah, so here's just some visualization of how our model predictions are different from the actual values. And there is a question.
Can you zoom in a bit? Sorry.
Yes, I can. So I can do that. Is it better? Okay. So yeah, here maybe this diagram is not super important. So this is something data scientists did. And they say, okay, our model now is saved as a pickle file. Let's deploy it. And then inside this model, there are actually two things. First, this dictionary vectorizer that turns our data frame into a matrix. And then the second step is our linear regression. And here we have some metric to evaluate the quality of the model, which we use mean squared error. And let's say I, as a data scientist, now want to experiment with different model parameters. Right? So what linear regression is kind of a very simple model, so there are not so many parameters here that we can use. One of the parameters is fit intercept. By default is true. And let's say we want to check what happens if we change this parameter from true to false, right? We run it and we see the result. And now I think, okay, like what was the result? Was it like, did it actually improve? So what I do is I undo the change. Look, okay, yeah, it improved. And then I do this. Maybe I take a note like with this, or I create a table. So it becomes very annoying at some point, like when, especially if you train something like XGBoost, where you have like million combinations of different parameters, then like you can easily get lost, especially if you take part in a Kaggle competition or something like that. I remember what I was doing is I was creating copies of these cells. Like here, I would do fit intercepts false. Here, fit intercept true. Right, and then like, okay, this one seems to be better. So this one is better. Right, I'll keep that one. So it's very easy to make mess here, to lose track of what's happening. So the first thing we want to do with this notebook is introduce experiment tracking. So for that, we will use MLFlow. And MLFlow allows us to track. It's a tool that gives us the possibility of tracking this. So instead of like creating spreadsheets with that, like there's a nice interface that allows us to track that. So I will install it right now. Okay, I lost connection. So I will install MLFlow and also install Bota 3 because we will keep all these models, the model artifacts in S3, which is object storage from AWS. So that's why we also need to install Bota 3. But it's also possible to store it in other cloud storages or locally. Okay, it's almost done. And now I will run, let me also enlarge it a little bit. So now I will run MLFlow. So here I say that we will use a local database for keeping all the experiments data, and we will keep all the files in S3. So this is location in S3. This is my bucket. It's empty currently. There is nothing here yet. So we tell MLFlow that we will keep all the artifacts there. It's done. So we'll do it inside screen. So in case my connection, I get disconnected, I still can use MLFlow. Okay, so I just run it. And now if I go to localhost 5000, I should see this experiment. Right? There is nothing here yet. And we will now start adding MLFlow to our notebook. So I'll close that. And so the first thing is we import MLFlow and we tell MLFlow here in this notebook, where the tracking server is. So this is the thing we run here. So this is the tracking server. We can access it through the browser, right? But we also wanted to access it from the notebook. So we need to tell the location of MLFlow. And by the way, I'm just curious, how many of you have used MLFlow before? Like other people? Okay, good. So yeah, I hope it's not too boring for you. For you, it will also hopefully be useful because I will show a few things like how to better interact with the model server, model registry. So here we say that, okay, this is how you access the MLFlow server, and this is the name of the experiment. Right? So each experiment should have a different name, obviously. And now I think if we refresh, we should have a new experiment here, right? Because it did not exist, so it created a new one. And now what I will do now is I will put all these things in one cell. So let me make it, yeah, like that, full screen. So I will just, what I'm doing right now is I'm taking all these cells, different cells with training, and putting it in one cell. And I will remove this for now. Yeah, let's also take this one. So everything we have done when it comes to model training now is in one cell. And what I will do now is I will add a with statement. So this is how you tell MLFlow that everything inside here is a run of an experiment. A run is like experiment contains multiple things. So multiple attempts, let's say. And right now we're doing one attempt of this experiment. And I think, let me just check how I do this. Yeah, with MLFlow start run. And now we can use MLFlow for recording some of the things we used in our, let's call it training pipeline, the training code, training script. So the first thing, so we made a decision that we will use only 3 features. But what if we decide to add a 4th feature? So that's also kind of a parameter of our experiment, like the exact features we use. So what we can record is these features, the names of the features we used. So here we do it by using this MLFlow.log params. And we say these are the categorical features we use, and these are the numerical features we use. Right, so here we record that. And then we have another place where we have the model parameters. So we can say MLFlow, it's the log parameters. So it can, like here, we use plural log params, and then we pass a dictionary. It can be also singular. Let's say it's fit intercept false, right? And then we just, no, we are not ready to execute yet because we have this metric here. So we also need to log the value of the metric. Just MLFlow log metric, and it's RMC. And then this is the value we log. Just in case I will print it here, so we also see it. And finally, what we want to do is log in the model. So I'll just quickly look how to do this. Yeah, I will copy this thing and now explain what's happening. So here we are saving our model. There are 2 things in our model, the dictionary vectorizer and the actual model, linear regression, as one pickle file. Right now we're splitting it into 2 parts. So first we separately save the dictionary vectorizer, and then we tell MLFlow that this is an artifact of our script, of our training pipeline, if you will. And we tell that MLFlow, please pick this artifact and store it. And then we also log the model. So we save the model to some storage. Right? So I will remove this part now. And so the code became a bit complex. So now let me run it. hopefully it works. Yeah. And so here we have a problem, right? So here we have fit intercept false, and if we want to set it to true, then we kind of have to do it 2 times. Right? What we can do is instead is we can create a dictionary model parameters where we list all the model parameters. In our case, it's just 1, but like let's say if you have XGBoost, then dictionary. If you have XGBoost, then it will be all the XGBoost parameters. And we simply pass this like that to our model, and then we use log params here. So now, so this is with true. So, and now we will experiment with false. Right. So now we run, we have made 2, I don't know what is that. So we did 2 attempts, 2 experiment attempts. And now we can check how it looks like in MLFlow. So we can see all these experiments here, like there is MRC. We can see when it happened, how long it took, all these things. So we will go with the last one. Here we can see the parameters. So these are categorical features, numerical features, and our fit intercept, right? So this way we can track all the important things for our experiments, right? And then when we select the best model, we can simply, I don't know, order. Let me hide. We can, let's say, order by RMSE, right? And then pick the best model and see, okay, these are the parameters that we're used to create this model. And the interesting part here is these artifacts, right? So here we have this dictionary vectorizer, and here we have the model, right? So then we can just take this artifact and already use it later. And yeah, so this part with the dictionary vectorizer is a bit annoying because we need to save first the dictionary vectorizer, then the model separately. But in Scikit-Learn, there is a very cool thing called pipelines, which allows us to put all these 2 things together in one model. So we will use this now. So we will turn this into a Scikit-Learn pipeline. It's from Scikit-Learn pipeline, import make pipeline. And now we'll create a pipeline with 2 things there. So the first one will be our dictionary vectorizer. And then the second one will be our linear regression. And I will put these things a bit up. Let's say here. Here. So we create our pipeline. This pipeline contains 2 steps, right? And now we need to clean a little bit. So this transformation will happen inside the pipeline, so we don't need this line anymore. And this one. And I'll just put this stuff here. Let me make it full screen. Yeah. And instead of now saying linear regression fit, we do pipeline fit. And instead of passing this intermediate step with a matrix, we pass this, I don't think I mentioned that. So like here we turn the data frame into a list of dictionaries, and this is what we will pass to our pipeline. I will show you how it looks like. So let's take a look at the first 5 records. So this is, so the first step, we take our data frame and turn it into dictionaries like that, and then we send it to the pipeline. So here we feed the pipeline, right? And here we do predict. So the code became a bit simpler. And then the rest, yeah, we don't need to lock artifacts anymore because these dictionary vectorizers, the vectorizer became a part of our pipeline. And then at the end, we just log the Scikit-Learn model, which is the pipeline. And so this helped to simplify the code. And also, right now, everything is in one place. Hopefully, everything works. It's probably difficult to follow along live. What you can do is, like in this repo, what you can do is just, there is already a ready version. Yeah, here with the pipeline. You can just copy and paste it. So let me run it. So what's wrong? Yeah, right. Okay. Now it works, and we are interested in this fit intercept true, right? So then this is our model. And now if we go to MLFlow and go back, so we have this 10 seconds ago. So this is the latest one. And if we look at artifacts, we have this model file. So we don't have the artifact anymore. And the parameters are the same. And this is our metric. And if we scroll down a little bit more, we will already see how to load this model. So what we can do right now, I will just copy this thing. So this is how we load. We don't need to import. So this is, so we save the model using this log model, and this is how we load the model using this MLFlow pyfunc load model. And this is the, each time we attempt an experiment, it's called a run, and each run has an ID. And this is what we use here to load the model. So it goes to MLFlow, fetches the model, loads this artifact. And now we can use this model to do predict. So let's say we want to make a prediction for this one. So what we can do, so let's say I am waiting, so I want to get an Uber. So I'm in this location ID and I want to go here, right? And the distance is, I don't know how many miles. So a request comes to the server with these parameters, and then the model outputs, it will take 8 minutes. Yeah, so that's how we want to use it. So this is already an MLFlow model that we loaded from MLFlow. And yeah, it's kind of difficult to keep track of these IDs. Right? So right now we know how to track experiments, how to keep these experiments somewhere in a nice location where we can see what kind of parameters were used, what kind of metrics were there. And MLFlow is not the only tool that lets us do this. Of course, there are other tools like weights and biases or Comet or other tools. So we handled that. We handled the experiment tracking part. But we have these models. We have these artifacts. And just using this run ID is not always convenient. So we can say that we have a model that is called, let me make sure so we'll call it trip duration. So we have a model called, trip duration 2 maybe. I need to create new model, Trip duration. And now I say, this model, this run belongs to this model, right? So this run belongs to trip duration model. So I can go now to this. So this is called model registry, where we put all these model artifacts we created during training. And now we can actually assign a tag to this model. We can say that this model that we just trained, we can promote it to staging. So staging is the area where we run different experiments. So there are like staging and production areas. So production is what is currently working in production, the thing that is receiving our requests. and responding, and staging is like something for internal testing. So we say this model looks good enough, it's an improvement over the previous model, and we want to promote it to staging so we can run some tests, right? So we just do this, we select staging, and now everyone, like all the ML engineers can, or all the services we have, can check, okay, what's the model that is currently deployed to staging. So they can talk to MLOps registry, and they will get the model back. So here, instead of using this this run ID and this long ID, we can say models. I will just copy it from here. So the URL changes URI. So we say it's models. The model name is trip duration, and we're interested in the model that is currently deployed to staging. Right? So this way, our service can talk. Let's say if our service is deployed to staging and we want to run some tests, our service would do this. So let us request the currently deployed model to staging, load it, and then we make predictions using this staging model. So this is the concept of model registry, and it allows us to like put all these artifacts and then easily retrieve them and give different tags. And there's one thing with this MLFlow and other experiment tracking and model registry servers also have this problem. So right now we have to depend on MLFlow being up and running. So if I do this right now, so let's say something happens with our MLFlow service. So yeah, it went down, maintenance, whatever, we don't know. So it stopped working, right? Now, if I go here and try to load it, it will say, hey, something is happening. Yeah, so it cannot load it because the server is down. And imagine that we work at Uber or a similar company, and we want to, so there is an increase of traffic. So we want, in addition to like our 2 instances of the service, have a third one. So we start the third instance to cope with the traffic. And this instance talks to the model registry and asks, hey, what's the model that is currently deployed to production? But the server is down, right? And then it cannot start. And then the 2 other models cannot cope with the traffic. So it can die. So this is not a very good situation. And MLFlow service becomes the bottleneck, the single point of failure. So this is not a good tool. Sometimes it's fine, but like in situations like that, we want to have something else. Yeah, so now it says I cannot load this model. But we're pretty sure, so all the things are actually stored in S3. So we can see like all the artifacts here. I don't remember which of them is our model, but we can be pretty sure that S3 will work, right? So because like there are many engineers in Amazon who maintain, and if S3 breaks, there are big problems anyways, everywhere, right? So we can be pretty sure that S3 works. So instead of relying on MLFlow to give us the location of our artifacts on S3, we can just record somewhere what's the location and then just go there to S3 directly and pick it up. And for that, so here we have this full path to S3. I just copied it. I will paste it here. So this is location to S3. And now, even though the server is down, I can still go to S3, fetch the model, and load it. So it's a good idea to a bit separate this logic from the this MLFlow service, so we don't get problems later if it goes down. And it should still work, right? But then, like, what's the use of ML registry, of model registry, right? If we don't want to use it, right? So how do we find out what is currently deployed in staging, right? And then we can use MLFlow API. So let me actually restart it. So we can use MLFlow API to talk to MLFlow and ask what's the artifact of the model that is currently deployed in staging. It will give us the S3 location, and then we can start our server. We can somehow maybe hardcore it into our Docker container and then start with that. So I will show you how to do this. There is like a simple script that we can use. So I will download it right now. So this is how the script looks like. It's not important, like we don't need to go into details of what the script is doing. It's just somehow communicating with MLFlow, and it gives us the details of what exactly is currently deployed in staging or production or whatever. Right, so we don't go into details. You can, of course, check the code later if this is something you're interested in, but I will show you how to use this. So we just use this script to ask, well, we first of all tell that our MLFlow lives here. Then this is our model name, and this is the staging name, right? And what it gives us back is the run ID and the source, right? And then what we can do is we can just take this source and put it into our notebook. Yes?
Can you hear me? Yeah. This gives you only the model which is tagged as the production model in metadata. So technically, still somebody could make a mess and not.
Yeah, of course,
not
you need
deploy
to have,
the actual.
yeah, so you need to have processes. So once a model changes, like once something is promoted to staging or once something is promoted to, I don't know, something else, then you need to go ahead and, let's say, if you use Kubernetes or something like that, you need to update your deployments. So something, of course, like it's not, like again, MLOps is more about processes. So you need to have a process in place. If you don't have a process, then of course you will have a mess. Yeah. Okay. So now we have this notebook, right? And we saw how to use MLFlow to save the model. We saw how to use MLFlow to load the model. Now we will turn this notebook into a script. So for that, you can, I don't know, save notebook as, or save and export as, where's Python file? Executable script. You probably don't want to do it with hand, but like this is how you can do this. And then like what you will get, this notebook is a Python file. Of course, there is a command somewhere where it is. Yeah, here. So it's using NB convert. And what I will do now is run this. So it will take the notebook that you saw here, and it creates this duration prediction.py file. And we will now, so it's basically the same thing we saw, just a Python file. So now we will edit it slightly. So we want to turn it into a script because like this notebook is not totally reproducible. Because like you need to open it, you need to execute cells, you need to remember like the order in which you execute cells. Ideally, you don't want to bother with all that. You just want to have a script that you execute, and you know that at the end of the script, you will have a model saved in the registry and all the results of the experiment also stored there. So now I will edit this a little bit. So we don't need many of the things. You can already find the end results here somewhere. Yeah, in the train folder, I think it's train.py file, right? So it's already there. So right now I will do editing. And we will create a function called lcode_run, and everything that we do, I'll just put imports at the top. So everything we run will run inside this function run. It's not very original name. I don't think we need these things. So now everything is inside run. we want to make it easier to run it on a different data. So the goal here is, let's say, next month, we want to train a model on the data from the previous month and evaluate it, and then again, and then again, and then again. So we may want to make it super easy. So we want to parameterize our script. So then the way I will do it, I will use date time from datetime import. Import date time. So then we will have our run function will have two parameters: train month and validation month. And then we will need to replace this long URL. I'll call it template URL. Here it's year and month, and like we need to have a leading zero here. So I will add. So this is like to make sure that we have leading zeros, and just in case we'll have also. Probably this is not really necessary, but yeah. So this is the template for our URL, and then we'll have train URL template format. So we have year, which will be train month, year, and then month, train month, month. And then we do the same for validation. And then we just use train month here and use validation run here. It's also a good idea to record it somewhere in MLFlow. You can maybe just record it here in parameters. Train month. Oops, and then validation month. But the rest we don't need to change, right? So this is our script. And then let's say we want to have a main function that runs this script with train month. I think it was year 2022. Go away. And month January. And then datetime object expects a day. So we can just put, we can just put any day here. So this is train month and validation month. Again, I'll just copy this and put 2 here. And if name main. So this is our training script. So it's parameterizable. So what we can do is we can put it in our Airflow or Prefect or some other scheduler, and then we can define these parameters through the scheduler. So we will not use anything like that here, but this would be the next step after we have the script. Or maybe cron job in Kubernetes or whatever. Right? But let's test if it actually works. So for testing, I do pip env run python train.py. Because I did not change the name. Okay, so now hopefully it works. Yeah, cool. So this is what we need to do because we don't want to deal with, most of the time we don't want to deal with Jupyter notebooks. And yeah, right now we can go and check if things actually work fine. So in our experiment, we should see that, yeah, so right now the source is train.py, not IPython notebook, Jupyter notebook. Right. So this is, so we are more or less done with the training part, right? So now we have a script. It's production ready, sort of script that produces model artifacts. Now we want to take that and serve it. And serving means creating a web service that we can send requests to and then get responses back. And here in this workshop, we will use Flask for that. And some of you probably use some other tools. So I just want to run another poll to ask you what have you used, or what do you know, which other tools you can use for serving machine learning models. Like Flask is one option. So you just create, like it's a general purpose framework. Bento. So SageMaker, Seldon, Flask, PyTorch. Yeah, Fast API. So Fast API is like almost the same as we use today, Flask, but cooler. Yes, there are many options. And so Streamlit and Gradio are actually very good frameworks. They let you create web interfaces for your models. So instead of like creating a REST API, you create a user interface. And let's say if you want to show it to some stakeholders or some other departments who do not know how to query REST APIs, you can put your model in Gradio and then share it with them. Very convenient. So in this talk, in this workshop, we will just use Flask. But there are specialized frameworks like BentoML, like Seldon, like SageMaker, like, in Databricks probably there's something too, that you can use to make it even simpler, because they're specifically for serving ML models. So here we will explain the concept and we will use Flask for that. Custom Flask API. So I will show you how to do this. How many of you have used Flask? Okay, so it shouldn't be too difficult for you. Okay, so we will now go to the serve directory. I will go one level up, and we will need to create an environment. Where it is? Serving, yeah. So we'll create an environment with different dependencies. So here I specify, and previously I specified the exact version of Scikit-Learn and the exact version of MLFlow, because we want to make sure that the models we trained previously in the training stage, are exactly the same as here. Right, so this is important, and also because we use MLFlow as kind of connecting layer between the training and serving. We use the model registry for that. We also need to make sure that MLFlow, the version of MLFlow is the same. Yeah, so now it's installing everything. Yes.
In the model registry repository, you also see the dependencies, right? You can see how it was trained. So
yeah. You can use that. Yeah.
But probably
so
there's
good
a lot
point.
of other garbage there.
So maybe I will show that right now. So when there is this conda YAML, and we see all the dependencies here. And since we kind of use ppanf, but like if we used conda, what we could do is we can just get this conda YAML file and have the exact same environment as was used for creating this model. Yeah, it's quite convenient. And in MLFlow, there is also actually integrations with SageMaker and probably some other tools where you can just click a button and then it would deploy to SageMaker using this environment. Anyways, I think, it installed. So now we want to turn this into take this model and wrap it in a Flask API. So I see that we don't have a lot of time. So I will probably just take the code I already have. So I will download it and I will explain what's happening. there. So this is the Python file that we have. So in this Python file, so the main logic is where? So here we load the model. Right? So this is the same code as I showed previously, except it's parameterized. Right? So we somehow need to pass the URI of the model to our service. So then it loads. And then there is this function that we turn into an endpoint. So when we start this Flask application, we will have an endpoint, this /predict, that will listen to post requests. And we can send like details about our write, and it will respond with the predictions. So this is kind of the entry point to our model. And then here we get all the data that we submit. Then usually when we serve a model, there should be 3 steps. So the first step is doing some preparation. So we want to, let's say, if we do some feature engineering, or if we do some data cleaning, like capping features at certain values or whatever. So there is like the preparation step, pre-processing step. Then once we prepared the incoming requests, we just send this request to the model. So we do model.predict. So the model returns raw predictions. And oftentimes we're not interested in raw predictions. We want to do something with these predictions. So for example, instead of probabilities, we want to have predictions in case of binary classification or something. So here we don't actually have any post-processing step because like the model already gives us minutes. So this is something we will send back to the user. But typically, most of the time, you have some post-processing step here, right? And then this is our response. So with these features that we received from the users, from somebody, so we prepare the features, or we create features, then we predict, and then we send the response. So this is how feature preparation step looks like. So it's super simple because we don't do any feature engineering here. There is a bit of pre-processing to make sure that it's actually strings, because our dictionary vectorizer expects to get a string here, not a number, but it's pretty much just taking whatever user send us and turning it as features. But like if you do some custom feature engineering, you would add it here, or data pre-processing. And then prediction is super simple, right? So we just do model.predict. And because it uses, like we can see here, it returns an array, right? Instead of an array, we want to have, so this is an array. Instead of an array, we want to have like the first result. And then we usually convert it to float, because like this type, if we look at the type of this data, it's NumPy array. And we want to have like a usual Python float. It's usually important when, like, because we create a web service, it needs to know how to deal with this data. So otherwise, if we don't do this, we'll have some errors. So this is like simple post-processing, very simple. Right, and that's all the code. Like if you know Flask, you understand this. If you don't, then you can just go through this code maybe after this. I think it's relatively straightforward. So the only thing we do here is like add this annotation or decorator. And yeah, this is how we get the data. So if you used FastAPI and FastAPI, I think it's a little bit easier. But yeah, the core idea is more or less the same. So we somehow need to expose our model. Now I will run it. Where it is. Yeah, before we run it, actually, we need to, we have these parameters here, right? So we need to know the model version, and we need to know the model URI. And I didn't talk about model version, like why do we actually care about that? Because here in the response, we return the prediction, but we also return the model version. it's quite important for us to know, for debugging purposes, to know which model made this prediction. So let's say if I want to get an Uber from the hotel to here, and it says it will take 2 hours, something is wrong, right? And then we as data scientists want to somehow understand which model made this incorrect prediction, so we can go back and try to analyze it. So we want to somehow keep a record of that. So that's why we return model version. And now I want to show you how we actually pass this. There's a question, yeah.
Just one question. Couldn't you get the model version from the load model that you passed on the URI?
Yeah, so this is how we will do this now. Or
No, you use two environment variables, one for the model URI to do the load module, and you are passing the model version explicitly.
yeah, it's just simpler.
Okay.
Because, for example, if we want to here use not allocation to S3, but we want to use this syntax with, because we can, instead of using this exact location, we can use model / trip duration / staging. Right, and there you do not know the exact model version.
Okay.
So we want to know, we want to be able to know which exact version of the model was used to produce this prediction. So then we can go to MLFlow like that, and we will know that, okay, this is the model, and these are the artifacts, these were the parameters. Then we can download this model and experiment.
Okay, thank you.
Okay, and now, so we need to have two environmental variables, so model version and model URI. So model version, so this is the model version, and model URI is this one. So these are two environmental variables. So I copy them and put them to the terminal. And now I do pip and run python serve.py. So now it can read these variables, and then it goes to S3, picks the model, and now we can serve it. So okay, I did not create a screen, so let me just quickly, or I can just use the terminal from here. Yeah.
Warning, I think, where it told you that it sees a slight mismatch, right? The first thing. Okay, that's cool. That's interesting. Yeah,
because like the thing you mentioned, like probably like it's more exact with all the dependencies. And here I did not specify, and some of the dependency needed something else. Because yeah. Okay. So, and here is the request we want to send. So I'm in the hotel. I want to come here. The distance is, or probably there is another service that computes the distance. So we have this information and we want to send it to our web service and to get the prediction. So I will put it here to the terminal. Go away. Yeah, so I used curl to query the endpoint, and this is the result. So we see which model version was used to make this prediction. This is the prediction, 19 minutes. Right, to get from that location to this location. And if we change, if we change something, I don't know, maybe make it a bit longer. Yeah. Well, our model is not great, I guess, at picking this up. But data scientists need to work on that. But you get the idea, right? So now we can serve our model, right? Does it mean our job is done? No, right? So we probably want to know more about like this thing we talked about with debugging models, understanding what's happening there, like if it makes bad predictions. Yeah, so we need to know when our model starts making bad predictions instead of like, I don't know, customer support reaching out to us saying, hey, like many customers complain that model is like the predictions we give are wild. So we want to catch these cases before it happens, right? So we need to have some sort of monitoring in place. So now we'll spend some time talking about this monitoring. And yeah, so this will be super simple. There are many specialized tools that do a very good job at monitoring. So I will talk more about the concept and things we can monitor. And for that, so we have our script, right? Serving, well, not script, like our application for serving the model. And what we can do in this application is we can start logging all the predictions and all the requests we receive. So we can put them somewhere, so later we can go back to these predictions and analyze. So I will call this function log, and it can log request and response. Okay, so something simple. So then we can have our log line, which will be request. So I'll just put both request and response in a dictionary. And log string. So I will just use JSON to convert this dictionary into a string. Import JSON. JSON dumps log line. And so now we have this line and we want to save it in some sort of log storage. So typically you would use something like Elasticsearch for that, or some storage can be, I don't know, some people can, like I know, I've heard about using Mongo or Postgres for keeping logs. It's totally fine, up to you. So what I like and do is sending logs to a Kinesis stream or some sort of like maybe Kafka stream, and then have something that reads from this stream and puts data to S3. So in AWS, it's very easy to implement. So you create a Kinesis stream and you create a Firehose connector, which like every 5 minutes goes to this Kinesis stream and saves data to S3. And then this, like all the requests you have go there, and then you can just go there and analyze. Right now, we'll do something super simple. We will just use our local file system for storing logs. So don't do this in practice. This is just for presentation purposes. Prediction log. So what we will do is we will simply append to a log file. So this is totally, you shouldn't do this. You should use like Kibana, or I mean Logstash or Firehose or some other login system. F out. Right. So first we will write this log string, and then we also need to add a new line. So that's a very simple function. So in our case, request will be this, right? And response result. So hopefully it still works. Let's see. Yeah, I need to re-execute it. Okay. So now we added login to our service. And now if I send another request, a file should be created here. Insert this prediction log. And we see, so this is our request, and this is our response. So for this location IDs and trip distance, this is our prediction. And this is the model that was used for this. One thing here is what would be also nice to have is for each request we send to our service is to require some sort of unique identifier of this request. So then we can immediately go to the logs and see for this specific request, what was the request, what was the response. So we need to have some sort of request ID. So here we can just ask the users, our clients, which would be other applications in our company, to always send the request ID. And yeah, it can look like that. So for example, we can have something like, so it could be request, and then, so we will have like nested structure inside this request. Right, would be something we get from the request, and there could be a write ID that we also get from the request. So right now we will not do anything with this write ID. Potentially we can somehow use it, but what we care about here is we get this write ID and we save it in our logs. Right. So now this is our request, and we need to modify the request a little bit. So it will look like that. So we have a write ID, which is some unique identifier for each request. And then there are some features for this write. So now our request should look like that. What? Come on. Yeah, so the response is still the same. We just changed the structure of our request slightly. The request we require, the format. So we say that all the requests that we receive have to contain write ID there. And this will make our life easier when we want to debug things. So this is how our logs look like right now. So we have the write ID in the request, and we have the response, right? And if somebody complains, we can always go back to these logs and check. We can check what was the model that was used for making this prediction, what was the features that were used, and what was the prediction. And then we can somehow try to run this, to reproduce the situation. But in addition to that, when we collect these logs for a long time, we can analyze these logs. So this would be something that we do regularly, let's say once per day, per week, per month. We can look at all the predictions that our model makes, and we can compare it with the predictions of the past data, of the data we use for training the model, right? And if we see that something is wrong, something doesn't match between these two data sets, then something changed in the data, and it means we need to do something with the model. So I'll quickly show how to do that. We will not use any tool for that. I will continue using the same notebook. Or yeah, it will make it a bit simpler. Zen mode. Oops. I just want to. So it's like kind of a new notebook. So we will have two things here. We will have a reference dataset. So this is the data we used for training or for validating our model. So I will take our validation dataset and we will use it as reference. So this is something we will use for comparing the predictions of the. So we are making some predictions right now, and we want to make sure that these predictions are still okay. So reference is what we will compare it with, and actual predictions, call it, I don't know, predictions is like what we have right now. So let's say today is the 6th month, right? So our model has been running for a couple of months. It was trained on the January data, we validated on February data, and we want to check that the data we validated on and the data we have now kind of match, right? And so these predictions, we can pretend that this is the logs. So it comes from these logs, right? So what we will do right now, what I will do is I will add an extra column here with predictions. And for that, I will copy this part. So it will be I don't know, data for predictions, prediction data, and then Y predictions, yeah. And then we will write it back to this data set, predicted duration. Of course, this data frame should also have this RIDE ID we talked about. Yeah, here we will not have it, but you can easily take the data we have in our logs and turn it into a data frame like that, right? So here we have our predictions with predicted duration. So we have our features that we used. We have the predicted duration. Then we can do the same thing with our reference data. Reference. Oops. It would be data frame reference, yeah. And now there are many things we can do here. So first of all, we can look at different. So one of the features we used was trip distance, right? Trip distance. What we can do is we can look at the differences between what we currently have in our actual data when it comes to trip distance. So I will use Seaborn for visualization. The data is kind of dirty, so I'll add a filter now. So this is how our data looks like. Let me go full screen. So this is how our data, current data looks like. I will add a label now. Label current. Right, and then we can also do the same for reference data. Reference. So we see that like it follows quite closely. So of course here it's visual, but we can, like if we have these two distributions, then we can compute some sort of distance metrics between these two distributions, like KL divergence or some other distances. I will not go into details. I just want to explain the concept. And there are tools like Evidently who do it for you, right? So they can look at the current distribution, reference distribution, and see if these two distributions are different enough. So then you take this thing, you turn it into a script again, or you use Evidently inside a script, right? And then you run it like every day or every week. You run it regularly. And if you see that this distribution, the current distribution and reference distribution start become dissimilar, so they are no longer similar, then you can alert, say, hey, something is wrong. Take a look at the data. Do something with the model. Right, and then, so you can do it with features. So in this case, I showed you a numerical feature. The other two features are categorical. So you can also look at counts and also compare these two different distributions there. But also what you can do in addition to that, you can look at predictions. So we have Y prediction, right? And we have Y reference. These are our prediction. And we can also look at how different the predictions are. So in this case, we see that they are quite close. So there is nothing to worry about yet. But if we see that the current one, the blue one, starts diverging from the reference, then we might have a problem. And I will just quickly show you how it might look like. So if I take let's say if I go back to 2020, and we can see how it actually looks like with 2020. You see, so here distributions, like current and reference distributions, they look quite dissimilar, so they're not the same, which means that we might have some underlying problems. So the data we used for training changed, so then we probably need to train our model again on the newer data. But because we have a script that we created, this train.py script, our life is very easy. We just execute the script, and we automatically have a new model without doing much. Of course, we would need to run some tests, deploy it to staging, run some tests. But if we make sure that everything is automated, then yeah, our job is becomes easier. So so that's more or less what I wanted to talk about. So now I want to maybe talk about more like implementation details. So we talked about one tool, MLFlow. We talked a bit about Flask. So you can replace Flask with specialized tools like we talked about, like Bend2ML, like Seldon, like Kubeflow, Kserve, Kubeflow serving, or SageMaker. When it comes to monitoring, there are tools like Evidently, Ylogs. There are also many. So these two, there's open source. There are also many non-open source models like. I'm trying to remember names. Like you can Google machine learning monitoring, and you will find a lot of vendors like Arise, Aporia, yeah, many of them. And then again, you can think like, do I want to host an open source thing, or I want to go with a vendor? I just pay them, and they do all this hosting for you. Yeah, so there are many things you can like take these concepts and apply with different tools. And if you want to learn more about this, so as I said at the beginning, so this actually is a condensed version of a longer course, a 10-week long course called Machine Learning Zoom Camp. So if you're interested, I think at the end there is a link to the course. So you can check out the course and see if you want to learn more. The course is free. Yeah, and with that, I think we can finish. So, like I don't know, I think some of you are with laptops. If you had any problems, like we can just talk now. And otherwise, like the main part is over. So thanks a lot for attending. Yeah. Yes, questions?
Just one last.
Yeah.
On a real case scenario, that we're building your model state.
How does it actually work? Because I'm assuming if you have a team of like 20 people, not everyone will actually just go there and click the button. So what's the process when you have a huge team to...
So ideally, so when you promote a model, when somebody clicks, let's transition this model to production, right? So what happens is like there should be a trigger when you say, okay, then the model is deployed somewhere. It can be SageMaker, it can be Kubernetes, it can be, I don't know, Bend2ML, someplace, right? So we have this deployment. So what needs to happen is this deployment needs to somehow get a notification that there is a new version of the model deployed. So in case of Kubernetes, let's say you have a deployment, and what you can do is you can update one of the parameters or two parameters of this deployment. And what Kubernetes will do automatically for you is it will roll out this update. So it will replace the current version with the new version. And if you use Kubernetes, it's very convenient because if something goes wrong, you can easily roll back. You can go to the previous version. You can say, okay, something's wrong. Let's use Kubernetes to roll back. and then it will go back to the previous deployment version, right? So with the previous version. And I think other tools like SageMaker or Lambda, AWS Lambda 2, they allow you to do this stuff. So the trick here is when it comes to specifically to MLFlow. So when you do something like this, or like nothing actually happens. So the only thing that changes is the state inside the MLFlow database. So in the free version of MLFlow, in the open source version, there is no way to add a hookup, at least to my knowledge. Maybe this is a newer version, maybe there is, I don't see. Like ideally, you want to have a hookup that is executed every time you, like a webhook or maybe something. Every time a model is promoted, MLFlow notifies something, and then it runs the script, and then it updates your Kubernetes deployment. So in case of MLFlow, free version does not support that. There are plugins for MLFlow that you can use to get this functionality. Or what I see often is implemented in practice. There is another service that talks to MLFlow every 5 minutes, and if it detects a change, then it triggers the Kubernetes deployment change. So that's how you do it.
And okay, got the technical specific. But if I'm the lead data scientist and I've got a junior data scientist that is actually deploying this model, so obviously I get it that it's promoting and that gets deployed into all my containers, that is fine. But how can I make sure that the model is reviewed on an automatic sort of way, a scalable way, from my seniors in the team?
Well, yeah, so you have multiple stages for a reason, right? So juniors should not be able to deploy to production, for example. So they should deploy to staging. And then you have a bunch of tests. So let's say junior deploys to staging, the model version is automatically updated. We have this Kubernetes deployment, and then we run some tests against this deployment. And then somebody needs to review these tests and say, okay, on this test, it looks indeed good. And then only then promote this model to production from staging. That's ideally how we should do this. The problem with MLFlow is, again, like everyone can do everything, right? So nothing prevents this junior that you mentioned to, just go ahead and deploy to production. So then you have to have processes for that. Did I answer the question?
If I can jump in on the question. Yeah. I know that the paid version on Databricks has their own, like, say, pimped up version of MLFlow, where they have this whole identity and access management, and you can set constraints who can really promote it. So in this open source version but as he said, this is just like a small open source example, but there are much more advanced tools. But one also way to control things is directly from CI/CD. Let's say in your DevOps platform, you can set, let's say in our company, we have very strict controls. And even I cannot deploy anything unless I get like 1 or 2 additional confirmations. Let's say if it's a deployment to production, to staging, I can do whatever I want. But so you can also in CI/CD configure different checks and boxes that they need to fill. Yeah.
Yeah, thank you. No questions? No.
Hello. So there are different platforms that one can use for the different steps. What should we consider to choose one?
Platforms. What do you mean by platform? Like
So for monitoring, you have a bunch of them, right? And then for logging, you have a bunch of them. How can we choose?
Yeah, there is no easy answer. You just try and see what works for you. Like, I guess you start with the requirements, what you want this tool to do, right? Like, why do you want this tool? Right? So probably there is a problem that happened in the past, problems most likely. So you can think like, how can I prevent these problems? And then evaluate the vendors using this criteria, I guess.
Thank you.
Or maybe one thing is like you try to work with an open source tool and then check vendors to see if it's easier to actually do it with a vendor, right? So you play with an open source tool, you like it, but some things are not convenient, right? And then you go and check vendors, like if this thing is not convenient with open source, is it actually better there? It's another approach. Okay, no questions? I also want to thank organizers of this fest for doing all that. It's an insane amount of effort to pull up something like that. So I want to... thanks.